Okay, dear students, so last class discussion electrostatic potential due to the point of single charge. So the single charge, for example, this is the single charge. So with certain point P from the charge R, the electrostatic potential for this one is equal to 1 divided by 4 pi epsilon naught Q divided by R. So this is the electrostatic potential due to the point of single charge. So this is discussion in the previous video. Okay, shall move to the electrostatic potential due to an dipole. So be aware of dipole in the first topic. So dipole means a pair of equal and opposite charges separated with the very small distance, that is called as dipole. So let's consider this is the dipole. So this is the dipole. So minus Q plus Q separated by the small distance. Separated by the small distance 2a. So this is the center of the dipole O. So this is point A, this is point B. Let's consider the dipole. Okay. So write down. So let consider an dipole. So let consider an dipole plus Q and minus Q separated by the distance 2a. The electric dipole moment, the electric dipole moment P is equal to Q into 2a, where Q is the magnitude of the inner charge and 2a is the separation between the two charges. Okay, let P be the point. Let P be the point at a distance R from the center of the dipole. At a distance R. So from the minus Q charge, the distance is R. So this is R. Then from the negative charge, the distance is R2. Sorry, from the positive charge, this distance is R2. This is the P. Let P be a point. Let P be a point at a distance R from O or center of dipole. So from minus Q charge the distance is R1, from plus Q charge the distance is R2. So then the electrostatic potential at point P due to the charge minus Q and plus Q. We already know for the single charge how much electrostatic potential is produced. So that is minus Q charge, it is a single charge, the distance is R1, this is the point. So plus Q charge, the distance R2 from the point P. Okay. So let's write down in sentence form. So the electrostatic potential due to the point of charge the electrostatic potential due to minus Q charge. Okay, due to the minus Q charge, that is V1 is equal to 1 divided by 4 pi epsilon naught. Electrostatic potential is a scalar. You have to take minus Q divided by distance is how much? R. So this is due to the minus Q. Similarly, plus Q. Okay. So make the notes. So this is the first one. Then second one, the electrostatic potential due to plus Q charge. So that is V2 is equal to or V minus Q or V plus Q. So that is 1 divided by 4 pi epsilon naught. It is plus Q divided by distance is how much? R. Then the total electrostatic potential, the total electrostatic potential at P due to V1 and V2. Okay. So that means the total electrostatic potential is how much? That is V is equal to V1 plus V2. Okay, V1 is known, V2 known. So we have to put the values. That is V1 value is how much? 1 divided by 4 pi epsilon naught minus Q divided by how much? R1 plus 1 divided by 4 pi epsilon naught so 1 divided by 4 pi epsilon naught minus Q R1 plus 1 divided by 4 pi epsilon naught plus Q divided by R2. So then V, that is the total electrostatic potential at P is equal to, so common, that is a Q divided by 4 pi epsilon naught. So then remaining, so 1 divided by R2 minus 1 divided by R. Okay. So to find out the R2 and R1 values. So how to find out the R1 and R2 values? You just modifications from the diagram. So put those R1 R2 values in this equation. You have this equation called equation number 1. Okay, so make the notes. There. So R1 R2 you have just this is the like a two sides are equal at this point. and this point. So this is just draw the perpendicular PA perpendicular C. So AC is a perpendicular to PA and touches the point C. And this is a backward. The line is to backward and join at the point C. So similarly, that is another one. BD is perpendicular. Okay, so BD is perpendicular. So BD is perpendicular. So that is BD is perpendicular to the PO. And AC is perpendicular to the PC and the OE is backward. You have to touch at the point C. So this is the modified the diagram. So on the basis of modified diagram, you have to find out R1 and R2. How to find out R1 R2? So looking this triangle ACP. So in the triangle ACP, in this triangle, so this is R1 is approximately equivalent to the PC, correct? So that means R1, that means R1 means AP is approximately equal to the PC, correct? PC approximately equal to the PC. So then PC is, so how can we writing the PC? The PC is writing PO plus OC, correct? So I written PO plus OC. So PO value is R, OC you don't know. Okay, put that is a PO value R plus OC. So how to find out the OC value? You have, this is a theta, this one is theta, this is a 90 degree. So in this figure, this is the 90 degree. So that is cos theta is equal to adjacent side divided by hypotenuse. So adjacent side is AO divided by, okay, so adjacent side, sorry, not AO, OC is the adjacent side divided by hypotenuse is AO. So then OC is equal to AO value is how much? This is A, this is a 2A means this is A, this is also A. So that is A cos theta. So instead of OC, I put the value A cos theta. Okay, so I write the PO value is R plus OC value is A cos theta. Okay. So then similarly R2 is, so R2 is equal to BP. So then BP is approximately equal to the PD. So that PD is how can we write it? PD PO minus OD. So PD is written PO minus OD. The PO value is known, that is a R minus OD. You have to find out by using the same method. So in this diagram, ODB triangle. So in ODB triangle, that is a cos theta is equal to, this is theta, cos theta is equal to adjacent side OD divided by OB. So then OD value is equal to A cos theta also. So I put the values. This is also A cos theta. So I got R1, R2 values. Put R1, R2. Put R1 and R2 values. R1, R2 values in equation 1. So then equation number 1 becomes, this is equation number 1 becomes, that is a electrostatic potential V is equal to Q divided by 4 pi epsilon naught. So 1 divided by R2. So R2 is R minus A cos theta minus R1 value is 1 divided by R plus A cos theta. Okay, so make the notes. So then V is equal to, so that is Q divided by 4 pi epsilon naught. So simplified, so that is R plus A cos theta minus R plus A cos theta. So divided by R square minus A square cos square theta. So plus or minus or get cancelled. A plus A cos theta plus A cos theta to A cos theta. That is V is equal to Q divided by 4 pi epsilon naught. So that is 2A cos theta divided by R square minus A square cos square theta. So we know that electric dipole moment is equal to Q to A. Instead of Q to A, I put P. Okay, so make the notes, dear students. Okay, next step. V is equal to, so that means we know that, so we know that P is equal to Q to A. So instead of Q to A, I put P, that is a 1 divided by 4 pi epsilon naught P cos theta divided by R square minus A square cos square theta. So if in case of R is very greater than to the A, so this is a R, this R is very greater than, the point is very greater. This separation between the two charges is very small. So that case, if R is very greater than to the A, so the A term is ignored. A term ignored. So why sir? So because the distance is very greater. Very greater. So this is a small things. So those small things are ignored or neglected. That is V is equal to 1 divided by 4 pi epsilon naught. So P cos theta divided by R square. So this is the electrostatic potential equation. So now, if the theta value is 90 degree, so this is the theta value. This the theta is equal to 90 degree means, so this is the dipole. Okay, this is a minus q, this is a plus q. So this is 90 degree. 90 degree. So the equipotential surface is 90 degree or perpendicular or normal to the dipole. So the potential is 0 because cos 90 value is 0. So that means we have write down the case. The first case is the case number 1, theta is 90 degree, the potential is equal to 0. The total potential on the equipotential surface is when normal to the dipole is 0. If equipotential plane is normal to the dipole, then the total net potential is equal to 0. Then second case number 2. So if theta is equal to, so case number 2, theta is equal to 0 degree or theta is equal to 180 degree. So that is V is equal to 1 divided by 4 pi epsilon naught T cos theta divided by r square. That is the potential. So cos 0 or cos 180, the value is plus 1 minus 1. Then the axial of the dipole is equal to plus or minus 1 divided by 4 pi epsilon naught P divided by r square. So this is the axial. So positive means this is a positive, this is negative, this one is positive. So this is called as the electrostatic potential axial of the dipole. Okay, so let's see in next class.